Hey, how's it going, everybody? Today we have a very good problem for you guys called the missing ranges. So, a very good problem. So, let's read the problem statement real quick, right? So, it says we're given an inclusive range, lower and upper, right, and a sorted unique integer array nums where all elements are within the exclusive range, right? So, a number x is considered missing if x is in the range lower to upper and x is not in nums, okay? So, return the shortest sorted list of ranges that exactly covers all the missing ranges. So that is, no elements of nums is included in the range, right? And each missing number is covered by one of the ranges. So pretty interesting problem, right? So the ask is pretty simple here. So we're given this nums array and we have this upper and lower bound, right? And our job, right, is to return the different ranges, right? That are missing in the array. So for example, right, we have the range of the 99. So we have the number 0. So the number is from 099 or 0, 1, 2, 3, 4, right? So on and so forth. We have 0, that's the anchor. We have 1, that's the second number in that range, but there's no 2, right? So we return the 2 to 2 as a range here because we have 3, right? So the range has to be continuous, right? So for example, the other one we're missing from, we go from 3, then we see 50. And we're like, oh, hold up here. That's not right. So it's our return. We're missing the numbers of 4 to 49, right? And then we have 51 to 74, which is this range between 50 and 75. And then we're also missing the range from 76, there's no 76, right, to 99, because we need to cover the whole range. Those are the missing numbers that are not present in the particular range, right? So example 2 is kind of very similar, where we have nums thing, right? Lower, upper, and there are no missing ranges because we have this range -1, right, and the lower and upper is -1, right? So we're good. So let's count what the ask is for each of the numbers that are missing, right? Return a set of ranges, right, that represents the ranges that are missing pretty much in that array. Okay, so pretty simple ask here. So what's the most intuitive way of solving this problem? What comes to mind to you? Yeah, so what's the most intuitive approach here? So the most intuitive approach to me would be to start a linear loop, right? And as we loop through, right, we check for the missing numbers, right? So what I would do, I would see for 0, right? I would look and see if there's a 0 in the array. I'm good. Boom. And then I increment the whatever iteration, right? So now expected number that I want, right, is a 1. And I see there's a 1 included in the array, so that's good. And then I go, right, and I see a 2. I come with 2, right, and then I see a different number than a 2. Then I'm like, oh, okay, so for this particular number, right, I'm expecting a 2 and I have a 3, right? This is a range that's missing because, I'm expecting 2 coming from 1, right? I'm expecting a 2 and I get a 3. So now I know that this particular range is missing starting from expected number that I have, right? Which is expected number I'm expecting is a 2, all the way up to this number that I'm on, -1. Okay. So now I have the range 2 to 2 because I'm expecting a 2, right? Then I increment it, then I go forward. And now I'm at 3. So now the next set of numbers I'm expecting is a 4 after the 3, right? So the 4, I have the 4, right? So now I go on to the next number. I see it's a 50. It's much greater than 4. So now there's a new range that I'm starting at, which is from 4, right? Starting from the expected number that I'm expecting to this current number that I'm on, -1. So, and then we keep doing that over and over, right? We start from 50. Now the next number after 50, I'm expecting is 51 in the array, right? Which is within the range that I have here, okay? So now I go here, I'm like, oh, this is not 51. So right now there are missing numbers in between, right? Because ideally it would have been, all the numbers would have been present right next to each other, right? So it's kind of what the approach here, okay? So that's why we record 5179. So now we run out of numbers, right? I might be saying that, oh, I'm done, but you're not actually done, right? There's still more numbers to there's still numbers that are missing because the upper bound is 99, right? And we stopped at 75. So we're gonna do a simple check, right? If so now I'm expecting 76, right? There's no 76, right? So if 76, right, is less than the upper bound, right? If the now that's expected number, right? When I'm done with the array, right, is less than the upper bound, then those set of numbers are missing in the array because we have not reached the upper bound. This is a very important case that we need to handle as we're going going through it, right? So let's kind of go in the code. I think the code would make a lot more sense to you guys once we get into it, right? So what I'm thinking is to have an expected number, right? So this is expected number. It's going to help us do a linear loop through the array. And also we have the expected number. We started at that is 0 actually, lower, because the numbers can be you know, you go up to negative 10 to the 9th power, right? So we started at lower, okay? And then we're gonna need a output result here, okay? So output result, we're gonna have res, and then we're gonna have a new array list, okay? All right, so we have this array list. So now what we're gonna do is to do a for loop. Okay, so now we're almost done. So we have the num, right, and nums. So the num and nums. So we're doing that loop. So what's next for us is to check, right, if the expected number, right? So if the current number that I'm on minus the expected number, if it's not equal to it, right, or it's equal to, it's greater than 0, right? Or right, if it's greater than 0, then I could safely say, right, that so the difference, right, because if it's the same thing, it would be 0, right? So yeah, that's what I'm doing here. So I do the check here. So now if it's not the expected number, right? So in those cases, what do we say that we'll end up doing is to start adding the missing ranges, right, between those two numbers, right? Because the gap is arrays as list, right? Start the gap, pretty much that where we found. So the gap starts at expected because that's the expected number that I'm expecting, up to nums, right? Num minus 1, right? Because num is present inside the array, so it's not missing. That's why it's not included, right? And also what I'm doing here, I'm going to every iteration, right, update the expected number to equal to the current number that I'm on. Not the current number, but current number plus 1, because that is what I'm expecting, right? Because I found a mismatch at the current number that I'm on, so I can't expect that number itself, because if we're already on it. So sorry, the next number after the number that I'm on, right, for 50, right, it's 51, right? Expect the next adjacent number to be 1, and so it's gonna be using the next iteration for that next number to check itself against the expected that we expect, right? And that's how we can detect those missing ranges when we do the subtraction, okay? All right, so we've taken care of all those cases inside the loop. So what next for us to do is to handle, right? If we have not still reached the upper bound, right? There's still numbers missing in the range, okay? So we need to take care of all the numbers from lower to upper. Very important now, right? From lower to upper, okay? So what's next for us is to we do if the expected number, right? Expected is less than or equal to upper. Okay. Then what's next for us to do is to just do expected, right? Is less than or equal to upper. Then we do the same logic here that I have here, guys, right? Which is now the range gets updated to expected all the way up to upper and including upper, right? So that's what we have here, right? Inclusive, okay? So what the ranges are, okay? So we've taken care of most of the stuff, right? So it looks like it's good to me. We start our expected at lower, and we go through the loop one by one. We check if, you know, there's a gap of greater than 0, if the number is not what we're expecting. Then we go ahead and add the missing ranges, right? And the missing range is always at expected because it's not present. That's why we have a gap. We have, no, it's not equal to 0, right? All the way up to the current number that I'm on minus 1, right? Okay. Let's press submit. Forget to press return the actual result, which is the most important part of the algorithm, right? So it looks like everything looks good. Let's press submit for pass all the test cases. All right, it looks good to me, guys. Right? If you guys found value, guys, understood the thought process in the comment section, guys, you make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video. Okay, so before we even go, just do this. Right, it's bothering me. So if what if I just do this? If the number, right, that I'm on is not what I'm expecting, does it still work? Right, it still works. Which is exactly the same logic that I was doing, right? So I just want to make sure that this is what the check is doing, right? If the number that I'm expecting is different than the number that I'm on, then we know that's a gap because I'm only incrementing the expected number every time by a 1, right? So if there's a mismatch, it's gonna get caught right there, right, guys? So it's kind of what I'm doing. So if you guys understood everything I talked about, again, subscribe, and yeah, I'll see you guys in the next one.